Hello, everyone. The third part of chapter 8, and it begins with effective nuclear charge, and then we move on to periodic trends. So let's begin. This is an important topic, especially when we get to the next lecture for chapter 9 with bonding, specifically electronegativity. And the idea here is straightforward. The word effective, nuclear, and then followed by nuclear charge, talks about the net effect of the charge of the nucleus on the electrons. So let's begin with what this paragraph is telling us. It says to you, and we're aided by this diagram right here, very helpful diagram. It says to us that shielding for multi-electron atoms, any one electron experiences both the positive charge of the nucleus, which is attractive. What it says to you is that this is an electron, it's negative. It experiences the positive charge of the nucleus. So it means it's attracted to the nucleus. Positive is attracted to negative, and negative is attracted to positive. And then it also experiences another charge, and that's the negative charge right here of the electron, meaning while these two are attracted to each other, these repel each other, or even the ones that are inner. So like this one and these repel each other. Those arrows means they repel each other. So those are repulsive versus attractive. We can think of the repulsion of one electron by other electrons as screening or shielding. That's what the word means. That the electron from the full shielding the electron from the full effects of the nuclear charge. So let's look at this diagram, and I'm going to erase this so we can look at it from scratch here. So let's look at the closest electrons to this nucleus. So we have phosphorus atoms. Phosphorus P has 15 protons and 15 electrons. You can verify this from the periodic table, which we've done a million times. Right here, 15 protons, that's the atomic number. And if it's neutral, it means it has an equal number of electrons. If you look here, you can count the number of electrons, and you have 15. And of course, we have 15 protons. That's what this means. Now, pay attention to what's happening to the first energy level right here. Right here. So those electrons love this first energy level because they are closest to the nucleus. In a very simplistic terms, that's really what it is. They have less potential energy because they're they're closest to the nucleus. But in doing that, they actually shield the electrons in subsequent energy levels, like the second energy level right here. They shield these two electrons, shield this nucleus from or take away from that charge of the nucleus when it's time for the electrons in the second energy level to experience it. So what it says here is that they shield two protons. Think about it. You have two negative charges. Here's one. There's another one. So they take away two positive charges. But these two experience a positive 15. They experience a positive 15. Now the next electron or set of electrons in the second energy level, they experience now, if you look here, they experience 13, a positive 13. A positive 13. And then the last one experiences even less. So look here, 15 is the nuclear charge. Here it is. That's 15. Minus 2, that's these two electrons right here. That's from the inner shell or from the core shell. Then followed by 8. 1, 2, 3, 4, 5, 6, 7, 8. Here they are. So 15 minus 2 minus 8 gives you 15, which means is that these electrons, the ones I'm going to circle right here, which we called before the valence electrons, experience a positive charge, positive 5 charge. And that's what we call the ZEFF, Z effective. That's the effective nuclear charge.